Welcome to This Explainer. Today, we're diving into a deeply frustrating challenge that, honestly, plagues so many growing product companies. You know the feeling, right? Your software keeps breaking after every single fix, your roadmap feels completely stalled, and you're just stuck. If that's happening, you're likely dealing with hidden structural codebase problems. And look, we get it. It's incredibly stressful. But here's the good news. This is an architectural issue. It's not a people problem. So today, we're going to uncover those hidden structural problems that are quietly slowing down your product delivery, and more importantly, how we can actually fix the whole shebang.
You fix a bug, two more appear. You delay the feature launch, again, to stabilize. A month later, the exact same cycle starts all over. And nobody can tell you why. Okay, if this sounds agonizingly familiar to you, let me just validate your frustration right now. If your roadmap is stalling out like this, it is absolutely not a failure of your engineering team. You don't have a bad team, and you don't have an impossible product. What you're dealing with is a code base that has fundamentally outgrown its own structure.
So, you might be wondering, why are the engineers closest to the code, the ones literally building it every single day, often the last ones to see this structural failure? Well, it's a massive blind spot, and it usually happens for three main reasons. First up, they've just kind of normalized the chaos. The dysfunction has crept in sprint by sprint, so it's basically become their new baseline. Second, there's no external benchmark. They really don't know if your bug-to-feature ratio is a total crisis because they only have eyes on this one system. And third, honestly, raising the alarm feels a lot like self-incrimination. The early trade-offs that caused all of this were made under serious pressure, so flagging them now means critiquing their own past work. Actually, this is exactly why McKinsey's research shows that organizations with significant technical debt almost never resolve it through internal effort alone. They just can't self-diagnose. So how do we know if we're actually dealing with structural damage? Well, we look for some very specific symptoms.
Sign number 1, the regression loop.
A software regression happens when you fix one thing and it mysteriously breaks something totally unrelated. It's like a giant, frustrating puzzle. Why does this actually happen? Well, it's because your modules are just too tightly coupled. They depend on each other in completely undocumented ways. So changes ripple unpredictably through the entire system. And without meaningful automated test coverage to act as a safety net, these breaks are reaching your actual users before anyone on your team even catches them. From a leadership perspective, it's totally maddening. I mean, you did exactly what was asked, yet somehow you were taking steps backward.
Moving on to sign 2, off-limits code.
This kind of instability creates a very real psychological impact. Basically, every structurally damaged codebase has at least one section that nobody wants to touch. Your engineers might call it legacy, or fragile, or maybe just the old system. They'll build features entirely around it, they actively avoid bug fixes anywhere near it. But here's the thing, this avoidance is not just technical caution. It is a straight-up architectural failure. When entire sections of a product become absolute no-go zones, the system is masking deep structural issues. It's what we in the industry call code smells. And this is exactly why a seemingly simple, everyday change suddenly takes your team 3 whole weeks to complete.
Which leads us to sign 3, slowed feature delivery.
Let's shift gears for a second and look at the very real financial and velocity impact that structural damage has on a business. $2.41 trillion. Yeah, you heard that right, trillion with a T. That is the massive annual cost of poor software quality estimated by the Consortium for Information and Software Quality. And guess what? Technical debt is responsible for the lion's share of that staggering loss. Development velocity decay is hands down the most measurable consequence of structural problems. You've got the exact same team, the exact same budget, but somehow half the output. Features that used to take days are now dragging on into weeks. Listen, your team hasn't lost their edge. It's just that the codebase has become entirely too hostile to work in.
All right, sign 4, pattern bugs.
Let's move away from those random anomalies and talk about systemic errors. Random bugs, totally normal part of software development. But pattern bugs? That is a massive red flag. We are talking about the exact same category of failures. Things like data sync errors, permission issues, or calculation inconsistencies just reappearing over and over in completely different parts of the system. You patch it 3 months ago, and boom, here it is again. Why is that happening? Because the actual root cause was never fixed. These recurring failures almost always trace back to duplicated business logic. Basically, the same rules were implemented in multiple places with just slight variations. You patch one, sure, but the others? They remain completely broken.
Sign 5, dreaded deployments.
Because things just keep breaking, we inevitably arrive at that extreme anxiety surrounding your release days. According to Google's Dora State of DevOps research, there is a stark, undeniable contrast here. On one side, you have elite teams who deploy on demand, often multiple times a day, with practically zero anxiety. On the other side, fearful teams. In a structurally damaged system, deployments become these terrifying, nail-biting events. They have to be announced way in advance, they're monitored with incredibly high tension, and they're always followed by this dreadful watch period where everyone is just holding their breath. If your team is deploying only once a month out of sheer fear, you are stuck in the absolute lowest Dora metrics performance tier. Every single release feels like rolling the dice.
And that brings us to sign 6, untrusted or missing tests.
A major reason for all that deployment fear really comes down to false confidence. Think about it. Without trusted automated tests, every single time your team touches the code, it's a huge, risky judgment call. And sometimes tests that pass in the pipeline but fail in production are actually way worse than having no tests at all. Why? Because they give you that dangerous false confidence. When we run audits using tools like SonarQube, we consistently find that test coverage is drastically lower than the team actually believes it is. And to make matters worse, that coverage is usually concentrated in the oldest, least changed sections of the codebase, meaning your newest, highest risk areas are left completely exposed.
Finally, sign 7, the bug loop. This brings us to the ultimate consequence for your engineering resources. Stripe's developer coefficient research reveals a pretty fascinating baseline. In a healthy codebase, developers spend roughly 33% of their time on maintenance and bugs. Not bad, right? But in a structurally damaged codebase, that number regularly exceeds 60%. Your engineers are literally trapped. You are hiring more and more developers, yet shipping less and less product, simply because over half of their time is swallowed whole by regression patches instead of actual new feature development. At this stage, your product is running your engineering team, rather than the other way around.
The diagnosis, our software architecture review. So, we've identified the signs. Now, how do we actually break this cycle? This is where an objective, independent assessment process, like a Forge9 software architecture review, comes in to strip away that familiarity bias. We evaluate 4 core pillars. First, architecture and overall system design. Second, code quality and structural integrity. Third, critical path test coverage. And fourth, your CI/CD pipelines and deployment practices. As independent engineers with zero stake in your past decisions, we are hunting for the exact structural patterns that cause really good teams to get hopelessly stuck. But the ultimate value of this process goes way beyond just handing you a list of technical complaints. We deliver a prioritized, written report that is focused entirely on business impact. We're going to tell you exactly what is causing the instability, why your internal sprints haven't been able to resolve it, and precisely what you need to fix first. This gives you a truly actionable plan to restore your delivery speed. It allows your team to fix that structural foundation while still actively building the product and actually moving your roadmap forward.
If you've been sitting there, nodding along to 3 or more of these signs today, your codebase desperately needs an independent review before you even attempt another sprint. Please, don't let your team keep spinning their wheels in the regression loop. Reach out and book a free conversation with our engineering team at forge9.com/contact. I want to leave you with one final provocative question to chew on. Right now, are your engineers actively running your product? Or is your damaged codebase quietly running your engineers? Thank you so much for joining me on this explainer, and we'll catch you next time.